Somewhere in our galaxy right now, there are planets drifting through total darkness, no star to orbit, no light to receive, no warmth. Just frozen, invisible worlds tumbling silently through the void between star systems. We've known they probably exist for decades, we've even detected a few. But we have no idea how many there are, where they came from, or what they look like. That's about to change. Because NASA just revealed its newest telescope to the world, and hunting these orphan planets is one of its primary missions. On April 21, 2026, inside the largest clean room at NASA's Goddard Space Flight Center in Maryland, scientists and engineers stood proudly around a gleaming silver and orange structure over 42 feet tall. The Nancy Grace Roman Space Telescope, years in the making, billions of dollars in development, and now finally, fully complete, was shown to the public for the first time. And the announcement that came with it was extraordinary. Roman is now on track to launch as early as September of this year, ahead of schedule, under budget, something NASA hasn't been able to say about a flagship mission in a very long time. But what exactly is this telescope going to do? And why are astronomers so excited they can barely contain themselves? To understand that, we need to talk about something called gravitational microlensing, because this is the technology at the heart of Roman's most ambitious science goal, and it's one of the strangest, most elegant tricks in all of modern astronomy. Here's the basic idea. Everything with mass warps the fabric of space-time. Einstein told us that over 100 years ago, and we've been confirming it ever since. When light from a distant star travels across the galaxy toward us, it follows the curvature of space-time. If something massive passes between us and that distant star, another star, a planet, even a black hole, the light from the background star bends around that object. The object acts like a natural cosmic lens, temporarily magnifying and brightening the light we see. Astronomers call this gravitational lensing. When the lensing object is small, a planet rather than a galaxy, they call it microlensing. And the effect is subtle, just a brief spike in brightness. A star appears to brighten for a few hours, maybe a day or two, and then returns to normal. If you blink, you miss it. And once it's gone forever. You can never go back and observe that specific alignment again. But here's the remarkable thing. You don't need to see the planet directly to know it was there. You just need to see its gravitational fingerprint on the light of a star behind it. That means microlensing can detect objects that are completely dark, completely cold, and emit absolutely no radiation of their own. It can detect things that are, in every other sense, invisible. And that is exactly how Roman is going to find orphan planets. These worlds, also called rogue planets, or free-floating planets, are planets that don't orbit any star. They roam the interstellar medium alone. Most of them were probably born the same way regular planets are born, in the swirling disks of gas and dust surrounding young stars. But planet formation is chaotic. During the early stages of a solar system's development, young planets interact gravitationally with one another in ways that can be incredibly violent. Larger planets can destabilize the orbits of smaller ones. Two planets can gravitationally duel for dominance, and the loser gets flung, ejected from the system entirely, sent tumbling into the darkness of interstellar space, never to return. Some rogue planets may also form on their own, collapsing out of gas clouds in isolation the same way stars do, but never accumulating enough mass to ignite nuclear fusion. They simply condense and go dark, adrift from the moment of their birth. Once they're out there, they're essentially invisible. They don't shine. They're too old and cold to emit infrared radiation detectable from any meaningful distance. They cast no shadow. They make no sound. The only way to find them is to wait for one to drift across our line of sight to a background star, and catch that microlensing flash before it disappears. This is incredibly difficult to do with ground-based telescopes. Earth's atmosphere blurs and distorts the incoming light. You can only observe a fraction of the sky at any given time, and microlensing events are so brief and unpredictable that you need to be watching the right patch of the sky continuously, with extreme precision, for months at a time, to have any real chance of catching them. Roman solves all of these problems at once. The telescope will operate from a point in space roughly 1 million miles from Earth, where Earth's atmosphere is completely irrelevant. Its primary mirror is the same diameter as Hubble's, about 7.9 feet across. But Roman's field of view is 100 times wider than Hubble's. A single Roman image covers a patch of the sky larger than the full moon as seen from Earth. And every image it takes will be captured at 288 megapixels of resolution. Scientists have noted that no screen currently in existence is large enough to display a single Roman image at full resolution. During its 5-year primary mission, Roman will conduct something called the Galactic Bulge Time Domain Survey, a continuous, deep observation of the dense star fields at the center of the Milky Way. It will stare at this region for hundreds of days at a time, monitoring hundreds of millions of stars simultaneously, waiting for microlensing events to appear. When one does, it will catch it, in real time, with unprecedented precision. Scientists estimate that Roman's microlensing survey will detect hundreds of rogue planets, possibly far more. And here's the number that puts everything in perspective. A major study published by NASA-affiliated researchers estimated that our galaxy may contain 20 times more rogue planets than stars. Our galaxy has roughly 400 billion stars. That means we could be talking about trillions, not billions, trillions, of orphan worlds wandering through interstellar space. Some estimates suggest rogue planets may outnumber star-bound planets 6 to 1. The universe could be overwhelmingly populated by worlds that have never seen their own star. Roman will be able to detect rogue planets down to the mass of Mars, smaller than anything we've been able to find before. And for each one it detects, it will extract information about the planet's mass from the shape of the microlensing signal, how the brightness of the background star rises and falls as the planet passes. Combine that with simultaneous observations from ground-based telescopes, and scientists will be able to build the most comprehensive statistical census of free-floating planets ever attempted. Why does that matter? Because counting rogue planets is one of the most powerful ways we have to test our models of how planetary systems form and evolve. If rogue planets are rare, that suggests planetary formation is relatively stable. Most planets stay where they're born. If they're common, if they genuinely outnumber star-bound planets by a factor of 6, that tells us something much darker about the universe. It means solar system formation is typically violent and chaotic. It means most planetary systems probably lose members. It means there's a vast dark population of worlds that planetary science has never even begun to account for, and Roman isn't stopping at rogue planets. Over the course of its 5-year mission, NASA expects it to discover tens of thousands of new exoplanets, billions of previously uncatalogued galaxies, and possibly even solitary black holes wandering through the galaxy, detected the same way as rogue planets, through their gravitational signature alone. It will gather 20 petabytes of data. That's 20,000 terabytes, more than any space telescope in history. It will also carry something called the coronagraph instrument, a high-contrast imaging system designed to block out the blinding light of nearby stars, allowing it to directly photograph the reflected light from planets orbiting those stars. This technology is being described as a critical stepping stone toward eventually imaging a planet like Earth around a star like the Sun. Roman is named for Dr. Nancy Grace Roman, NASA's first chief astronomer, and the woman most responsible for convincing the agency to build the Hubble Space Telescope back in the 1960s. She understood, decades before the technology existed, that putting a telescope in space would transform our understanding of the universe. She was right then, and the instrument bearing her name is about to prove it again. The telescope ships to Kennedy Space Center this summer. The launch window opens in September 2026. Once it reaches its operating position 1 million miles from Earth, it will begin one of the most ambitious observational campaigns in the history of astronomy. And somewhere out there in the dark, frozen, silent, drifting through the space between stars, there are trillions of orphan worlds that have been waiting, without knowing it, to be found. Roman is coming for them.